All right, welcome everyone. It's amazing to have all of you here. I couldn't be more excited. It's been a really exciting year for Apollo. By far the most momentum we've seen yet. I could talk about numbers, I could talk about a lot of things, but just look around the room. We sold this out in, I think, about a week. We have over 100 of you here who are either in production with GraphQL or moving that way very quickly. And this is just one event. We are hosting our third annual GraphQL Summit this November here in San Francisco. This is our 2.5-day annual conference for GraphQL. Summit.graphql.com. Tickets are on sale now. I would not wait too long. I suspect the same sort of demand is going to come from people around the world as they come in to find out more about what's happening in GraphQL. So don't wait on Summit. Another thing I love about what's happened here is it's not just Bay Area companies that have gone down this path. One of the ways we help companies is with a consulting partner program. And two of our newest partners are Oye out of Paris. Oye works with a number of top-tier European firms in luxury brands, automotive, banking. And Poetic Systems out of Houston, who among their clients include a number of oil and gas concerns. So it's really something that's spanning companies of all sizes, sectors, geos, consumer and enterprise both. And I think that's really exciting for a technology at this stage and with this level of importance. So we've had the fortune to work with a lot of teams that are evaluating GraphQL and putting it into production. And we often see this sequence where teams go from some POC to a first safe small feature to the big thing and then to everything. And what we hear over and over from people either going through this path or looking ahead a few steps is, how do I do it? What's the right architecture? What are the best practices? How do I make sure I'm planning right, not just for what I want to ship today, but for what I want to ship tomorrow? How does this fit into my other systems and my investments and the other priorities that I have at the company, either in product engineering or infrastructure or elsewhere? So we wanted to have an event to help you answer exactly those questions. Whether you are already in production and looking to expand, whether you're evaluating GraphQL for 2018, we want to show you what's new and exciting. We want to point you in the right direction. We want to help you get answers to those questions. And my goal is to give you the confidence to move further and faster with GraphQL and with Apollo. So I'm going to start off showing a few things that I'm excited about, some stuff that we've been working on in response to what we've learned from the teams we work with. But we've got a whole day lined up for you that I think you're going to like. So you'll hear from both Brigade and Airbnb. The former has been in production with GraphQL for a year and change, and they have a lot to share about their experience. The latter is evaluating an architecture for going into GraphQL organization-wide, and obviously a large team with sophisticated requirements. So you'll hear how they're thinking about their architecture. We've got two of the engineers here at Apollo who work closest with both our open source contributors and with the commercial customers for whom we do architectural reviews, developer support, and so on. As a matter of fact, both of them have come to us by way of companies that were running GraphQL and Apollo in production, and they've brought with them a lot of their hard-earned experience and the knowledge that they accumulated over time, and they've baked that into our software, our guidance, and our best practices. And Cloudflare is here. I'm really excited about a partnership that we have with them. So you'll hear their perspective on Apollo, on GraphQL, and how they see this fitting into the move toward the modern internet architecture and the way that we build apps in the future. So just to start off, I want to get on the same page about what GraphQL is, what it's for, and just have a common language that we can use going forward, because it's so many things to so many people. And I'll start with what we used to have, and it really wasn't so long ago that when we talked about app dev, we had a back end talking to a front end. And none of us have this anymore, I'm sure, but it wasn't that long ago, and a lot of the heritage and a lot of the the systems and the APIs and so on that we use are still anchored in many ways in this original picture of what software development looked like. And I think two things have really happened that render that no longer the way we do things. The first, of course, is the data that we use when we build apps and the data that we want on the screen is no longer coming from a back end. It's coming from a whole fleet of services that we have. Those services might be written in different technologies. They're built around a different set of considerations. But there's a lot of them now, and as an application developer, you're going to have to draw from that whole suite of them to do your application development. And the other change is we're writing for so many different new platforms now. It's not just web and mobile. It's chat, it's IoT, it's wearables, it's VR, right? It's Alexa. Just on down the line, Apple News, AMP, these are platforms that many of us need to be on. And so we're faced with a big challenge, which is how are we going to connect all this data to all these different kinds of features we need to build at ever-increasing velocity? And the answer is simple. Instead of defining specific APIs to draw data for each of those services to each of those applications, which means writing and maintaining a lot of code, we're going to use GraphQL to let our service layer describe the data it has and let our clients describe the data they need. And what goes in the middle is Apollo that manages how the data moves between the two. So if GraphQL is the language we use to describe the data we have and the data we want, Apollo is the implementation of that. It's akin to how SQL allowed us to move from this handwritten model that moved data in the enterprise to a model where you could be descriptive and agile about collecting that. And Apollo is your implementation. It's the set of tooling, and it's the set of systems that you use to make that a reality. And that's one of the big messages I want to focus on, and you'll hear throughout the course of the day, is I think what you'll see through these talks is that Apollo is really about tooling and integration, and it spans the entire stack from development through production, from front end through back end. So there's a lot of advantages to GraphQL and Apollo. You can talk about less data on the wire. You can talk about not having to write REST endpoints. But I think what you'll find is the further down this path you go, the thing that really makes it sing and the thing that brings you the biggest benefits is the changes it gives you in your tooling, your workflow, the way you do application development. And I hope you'll get a taste of that over the course of the day. So let me give you an example of what I mean. One of the best practices in GraphQL development, Brigade will talk about this in a little bit, is what we call schema-centric development. The idea being that your GraphQL schema, the menu of all the data you have in your organization, is the anchor for how your front-end team and your back-end team can rendezvous as you build features. And it gets you some really basic fundamental stuff right off the bat. So tools like Graphical or GraphQL Playground that let you interactively explore that schema and issue queries end up being a really valuable part of the GraphQL development experience. But as you go down the path, especially with larger teams or as you expand GraphQL to more than just your first app or your first feature, you're going to need a way to manage that schema. And you're going to need a way for when multiple teams want to rendezvous around it, a way to make sure that there's a workflow that allows them to collaborate in a safe and effective way. So you're going to need tooling. And that tooling is going to have to be tied in with your whole development process around the schema, how it's produced, and how it's consumed. So something many teams have told us they would like is better tools for managing the schema, managing changes, and validating those changes. And we've been working on just that, and I'm excited to show you some of what we've built. We're just putting the final touches on this stuff now, so this is coming out imminently. And here it is. We've added to the Apollo tooling the concept of schema validation. It's a really simple, important idea that every time you make a change to your schema, Apollo is going to validate that change against a set of rules and give you the tools and the information you need to make sure you haven't broken anything and to coordinate those changes across the different parts of your stack. So whether it's adding fields, changing types, deprecating fields, all the things you need to do in the course of managing that schema, we can now have a structured way to talk about that and fold it into your development process. Why is that valuable? Well, obviously you don't want to break your API, right? So this gives you positive control over that API. But it goes further than that, and I'll try to paint you a picture of why we're so excited about this direction. So if you have the ability to validate a particular proposed change, what better place to integrate that in than your CI and your source control framework, right? So along with the schema validation tools, we have built an integration with GitHub for this. So GitHub's been a long-time partner in the GraphQL world. They're one of the first companies to release a public GraphQL API. And just a month ago, they built a checks API for allowing you to plug into a source control workflow that allows you to run these sorts of schema validation checks as part of that. And so I'm really excited about this because what we've got now is GitHub, Circle CI, Apollo, all working together, all giving you that confidence, especially as your teams are larger and it's more of an arm's length collaboration, that you can move quickly and have confidence about the impact of changes you're making as you go. So how does this work? Well, the new stuff is built into Engine, which is our cloud service that tracks field by field, query by query use of your GraphQL API. So Apollo Engine captures exactly what data each GraphQL client is using and exactly how that data got assembled in the GraphQL layer from the underlying services. So this data is a really key ingredient in the tooling and in schema validation. So let me be really clear. We're not just checking the schema for static compatibility with a previous version, something like changing the name of a field. Who's going to do that anyway, right? We're actually replaying all the queries that we've seen recently from active clients against the proposed new schema. And that's really cool because this is something that's only possible because of the structure and the static strong typing that comes with GraphQL. We don't have to have a running server with this new schema. We don't have to deploy your proposed changes anywhere. You don't even have to have an implementation of the new schema. Instead, we can take advantage of GraphQL's structure to give you a way to validate the direction you're going against what's out there, and to give you even more than that, a way to understand the impact of the change you might want to make on not just your first-party clients and your first-party API use, but on your third parties, your partners, your external clients, anybody who might be making use of your data. And I think that's a really important example of what I mean about tooling across the stack and why the tooling is really the thing that is exciting about GraphQL long-term. Because with the right tools, there are things that are now possible that just don't really have an analog when we think about REST APIs or the old way of moving data around. So when we think about how to do API versioning or how to manage different variants of the API or a data source, Apollo gives you a way to think about that in a much more structured, much more forward-thinking, much more flexible way that I think opens up a lot of exciting possibilities. Of course, that raw data is valuable for a lot of reasons. So inside Engine itself, you can see all kinds of metrics about which parts of your schema are used, what a query cost, what deprecated fields are still in use. This is something we've just released that I'm really excited about. We can give you a field-by-field view of exactly how expensive your data is. So for each piece of your schema, you can know, is this a cheap thing to ask for, an expensive thing to ask for? How does that change over time? What is it going to mean when I add this piece of data to my UI as I'm building a feature? Again, you don't have to go into production to know this. We already have the information. So the idea that we can distribute all this, I think, is really interesting. And it's not just locked inside Engine. Our philosophy on this is you want to push that data into every other system you have, because that data enables these workflows and this new way of doing application development that I think is so exciting. So the message is you don't have to change your systems. You don't have to upend your workflows. You don't have to walk back from investments you've made in logging, errors, APM, metrics, monitoring, alerts, all those sorts of things. It's the other way around. Apollo makes those things more valuable and makes those things more interesting because the tooling spans the entire stack. And that's an illustration of what I meant when I talked about how, as you go further down the GraphQL adoption path, I think what you'll find is this stuff makes it just an incredibly interesting and exciting way to do your software development. It's really the secret sauce that makes it such a transformative technology. Okay, I want to talk about the box on the left for a few minutes. So when we talk about running a GraphQL query, one of the important parts of that story is what we call the server, which is the piece of code that translates the incoming query, the description of what data you need, into some set of fetches from the underlying data sources. And I don't think it'll be a surprise to anyone. We've heard over and over, this is one of the hardest, most annoying parts of adopting GraphQL today. How do I build and run a GraphQL server? And I have great news. That's about to get a whole lot easier. Something we are really excited about, and this is the second big thing I wanted to talk about today, is Apollo Server 2, which is our GraphQL server that's specifically designed for standing up a GraphQL layer over the APIs and the services and the data that you already have today, doing it incrementally in a way that integrates with all the systems, processes, and workflows you have, and rewarding those investments. Apollo Server 2 is in beta today. It's recommended for production use, the final version probably in a few weeks. And I want to show you a little bit about what's inside of it. The first thing I want to talk about is it's 100% open source JavaScript. And there's two things I want to mention inside this. The first one is JavaScript. So one of the best practices we recommend for teams is building your product-facing schemas using JavaScript as the language. And the reason's pretty simple. It lets the product team collaborate and be part of that GraphQL schema and its development and its evolution. What we have seen from teams that don't build their GraphQL layer in JavaScript is they often miss out on some of the productivity benefits that they were expecting. And the reason is that there's just no good way for the product team, the team that's actually consuming this data, to be able to contribute and participate in that. JavaScript is a best practice we recommend, and that's allowed us to double down on our investment in building out JavaScript-specific features and patterns in the server that make it easier to stand up that layer and easier to develop that layer. The other part of this is open source. So in the past, we've distributed some features like caching or the instrumentation that powers Engine as a binary proxy that sits in front of your GraphQL server. And we had that architecture because we wanted to support servers built in lots of different languages, lots of different technologies. We still support that. In fact, we've made some changes to our tracing APIs, for example, that make it easier to use servers from other languages. But as we've gone further down the JavaScript path, this has allowed us to make more investments in native JavaScript versions of these features, things like caching and instrumentation. And that eliminates a whole set of concerns around deployment and operation that were an issue for some teams when there were multiple parts to this server picture. So this is a much simpler and, frankly, better architecture for most teams, and it's the direction that we will be investing more and more in as we go forward. So JavaScript is one best pattern for building servers. Apollo Server actually bakes in a ton of best patterns that we've learned from working with teams that are running GraphQL into production. And it's an evolution of the tools and techniques that these teams are already using, all wired up and organized for you to use out of the box. So for example, I mentioned engine integration and the schema management tools I showed you earlier. Apollo Server 2 includes stitching, which allows you to combine multiple schemas into a single schema. We'll see some examples of that throughout the day. It includes error management across the entire stack. Here's another area where GraphQL has a lot of flexibility, but now we've brought more structure to it. So there's a consistent way of thinking about errors and error codes and how to use them and how the client and the server organize themselves around that. Another best practice we've put into Apollo Server 2 is caching. So one pattern we recommend for caching is what we call whole query caching. And the idea here is that your GraphQL server assembles a cache control policy for each incoming query based on either cache information coming from the underlying services or cache information or policy that you've built into your schema. So CNBC, for example, uses this architecture. They run their Apollo server behind a CDN to power a content site that they run. And the advantage here is that the majority of clients that are accessing this data don't have to find their way to the origin at all. The CDN can serve those requests directly from the edge of the network. And that, of course, is because in a media property like this, the data tends to have longer TTLs, and so many of these requests can be entirely served without going back to the origin. That's really valuable. It saves, I don't have to explain why you want a CDN, but there's a lot of good reasons for it. And it's an important part, I think, of an architecture that has high request volumes like this. So that's great for media, but what about e-commerce or SaaS, or the kinds of applications where you have a mix of both long-lived and short-lived data as part of the same GraphQL request? So for that, there's a different pattern that we recommend that we call partial query caching. So here's a query that we have, this is written against the schema of TV4. They're a Swedish media concern. I think they run the largest cable or the largest television station in Sweden. And this is a product that's somewhat like Netflix. So you've got a TV show with a set of seasons, each of which has a list of episodes. And buried in the bottom of that query is for each episode, we want to also know how much of that episode has the user watched, so that we can put the little play bar to see where you are in your TV watching habit. So the stuff in white has a pretty long TTL, right? Episodes don't change much. The stuff in orange is probably not cacheable at all. And in fact, that's exactly how they've set up their system. So they've got two services. One of them is a search service that has all the data about the episodes. The other is the personalization service, which is where the information about where you are in your viewing lives. This is a really common pattern that lots of teams use to avoid having to execute the full GraphQL query each time a request comes in. So what you expect to happen here is when someone queries for their user-specific information about series 98794, hopefully we don't have to go back to the search service every time to fill in that data. We just have to hit the personalization service. So a lot of people are doing this. The problem is none of it's standard. Everybody's got their own ad hoc implementation of something like this. We wanted to make that a lot more out of the box and a lot more straightforward and pluggable. And let me just show you quickly how that works. So this is GraphQL Playground. We've got that query up on the left. And when I run that query, we're going to see a trace in the bottom right that actually shows the timing of how that request was fulfilled. And so what we see is a chain of requests that corresponds to the underlying API calls. We had to get a couple different things from the search service, and then once those were complete, which took 400 milliseconds or so forth, the rest of this was grabbed from the personalization service. It took another 100 milliseconds. We've wired this up with partial query caching in Apollo Server, so if I run the same query again, we're going to see a different result. If I can remember how to drive the slides. Here we go. So when I run the query again, I get just a few milliseconds to resolve the series data, and then, of course, that same 100 milliseconds to go grab the personalization data. So this is an example of what I'm talking about with partial query caching. It's a pattern we recommend doing. What's in Apollo Server 2 is something I'm really excited about called data sources, which is a pattern that builds this in for fetching data from REST endpoints. It's a replacement for the dataloader API that a lot of teams use today. Dataloader is not a great match for REST endpoints because it was really just built against a different kind of API. And the big thing you get with data sources in Apollo Server 2 is you get cross-request caching. So when your REST endpoints return data that's stamped with cache control information, or if you like, you can do that manually in your Apollo server, you get to store that data in a pluggable architecture, whether it's Redis, Memcache, or something else that you can add. This is all 100% open source, so it's extensible in any way you need, and take advantage of that pattern I showed, but in a way that integrates with all the tools and such that we have for you in Apollo. It's a really good fit for personalization data. As I said, e-commerce and SaaS, there are a lot of design patterns that fit this. And there's actually two interesting things here. So the first one about using data sources is it rewards teams that have invested in great service APIs. So this is interesting, right? If you have gone down the microservice path and you've broken out your API into small pieces that are modular, that each have their own policy, their own cacheability, that's actually to your advantage in GraphQL. GraphQL makes that a great investment because that allows us to be more and more sophisticated about how we answer queries that draw from those different data sources with different properties. So GraphQL and Apollo actually elevate those investments, and it's a big win for the infrastructure team, not just product engineering. The other thing I like here is it shows how great it is when your schema reflects the way your products actually want to consume your data. So this is a very natural query to write. The fact that that stuff that's personal is buried in the middle of the query isn't a concern for the product engineer. And what's great about having good, strong tooling around GraphQL is that it makes product development very natural by writing sort of the obvious thing you want, but then it gives the infrastructure team or the GraphQL layer owner ways to optimize these sorts of queries by taking advantage of patterns like partial query caching. So you might go back to that screen I showed you with the field-by-field cost. You might look at the distribution of queries that you're seeing from different kinds of clients, and that might inform either cache control changes you want to make to your service layer or changes you want to make to how your Apollo server executes those queries. All right, I want to show you one last thing. This one's a little different, but I'm really excited about it. So I talked about how annoying it is to run a GraphQL server. I think one trend that really helps us here in the long run is serverless. GraphQL is a great fit for serverless, right? It's fairly stateless. And what product engineering team really wants to run servers at all? So I think there's a really great architectural alignment there. And we've also talked about CDNs in GraphQL. I think you're going to want a CDN in your stack for 1,000 reasons. But the idea that you can have your data as close to the user as possible is, I think, a pretty sensible direction to go. So we have been working with Cloudflare on something that I think is pretty cool, which is a build and configuration of Apollo server that's actually running inside Cloudflare's edge network. And it uses their new Cloudflare Workers platform. So, in fact, that demo I showed you a moment ago of running those queries against the TV4 schema, that's actually running inside a Cloudflare edge worker. That's JavaScript running on the edge of the network. There was no standalone Apollo server there at all. That edge is talking directly to the REST endpoints that provide that data. It's got everything I've talked about. So whole query caching using Cloudflare CDN, of course. Partial query caching, caching resources all the way at the edge. It's got engine instrumentation, so you know exactly what data is being queried and what it cost. You saw the request tracing in the Playground app, for example. And it gives you all the analytics that then drive all those other tools we talked about, like schema validation or pushing that data into systems like Datadog or Sentry or whatever else you may need. So all of that running on 151 or whatever it is now, points of presence all around the globe. That's the architecture. Now, everything I showed you up to this point is available now. It's stuff that you can use today or it's imminent. This one's a bit further out. This isn't something you're likely to put into production over the next month or two. We are very interested, though, in getting your input and your feedback around this idea of CDNs for data with GraphQL. And so I wanted to invite everybody to join an early access program for this. If you go to apollographql.com/edge, you can sign up for that. We're still learning the right way to think about GraphQL execution at the edge of the network. I think it's a really interesting direction You'll hear more about that at the end of the day from Cloudflare, but we want your ideas. So if this is of interest, please let us know what you're thinking and let us know what you'd like to see, and we will look forward to working with you on that. So I wanted to show you this not just because I think it's exciting in its own right. I think it also hints at where the GraphQL architecture is going longer term. You're going to hear from Airbnb in a few minutes about, a couple hours actually, about a two-level architecture that they use for GraphQL where you have multiple teams each maintaining part of the schema and then a GraphQL layer that stitches those together. And I think it's actually going to be more complicated than that. You're probably going to have multiple stitching schemas like this. So you might not just have a main schema, but you might have canary or feature flagged schemas or admin-only schemas. And we've talked about CDNs, which add another piece to the top of that. So over time, your GraphQL layer isn't going to be a single server. It'll be a constellation of services that are each responsible for a portion of the schema and a portion of query execution, right? And all that's going to be open source, all running different builds and different configurations of your server, and all instrumented so that you understand precisely what data each client's requesting and exactly where and how that request was serviced through that set of services, all available for all of the systems and the tools that need that data as part of your development workflow. So we call that GraphQL orchestration, coordinating all the parts of execution, including CDNs, extending through the whole development cycle from your GitHub CI all the way through your metrics and your APM, integrated with all your existing tools like Datadog, comprehensive 360-degree view of how all your data is flowing through your system and what clients are asking for it and how they're accessing it. That's our vision of where GraphQL and Apollo is going. I think it's a really exciting direction that's going to reward the teams that adopt this technology and embrace GraphQL today. So we're here to work with you, whatever way is best. Open source collaboration. We have a support and training arm that can help you move faster and train teams. We can work with you on technical reviews and architectural reviews and a custom set of best practices. As I mentioned, we have implementation partners that can help with GraphQL development. And we have a really vibrant community Slack channel that I encourage you to join. So however is best for your team, the whole idea of today is to give you that picture, give you that information about what's next for you, and really invite you to tell us what you need and how we can most help. So thank you very much.